Number one, this is a parabola. It's a U shape. The number of solutions in it doesn't have, so there's no x-intercept. So there's no x-intercept, so be no real solutions. Okay, so they're going to be, so no real solutions. So you're going to have imaginary solutions. So if it's no real solution, the discriminants going to be negative. What is a discriminant? So the discriminant is the b squared minus 4ac. For parabola, so let me give you a quick review. Parabola, okay, is the graph of ax squared plus bx plus c. And it's going to have the U shape. Okay, so those kind of a quick uh, snapshot of what parabola is. Uh, Move on to the next one. So there's two x-intercept. So when there's two x-intercept, okay, so there's two x-intercept, it's right there. Then you're going to have two real solutions. So there's two real solutions. The discriminant is going to be positive. Now you only have one x-intercept. So when one x-intercept, you're going to have one real solutions. So the discriminant is going to be the zero. So think up two numbers time equal negative 14. So you're going to need two numbers multiply equal to negative 14. And the same two numbers when you add, that's going to equal to a negative 5. So you just kind of think, do it in your head. Um, 2, 7. 2 and 7. But we want the negative. So it's going to be um, negative. So let's use different colors here. So it's going to be a negative 7 and 2. Negative 7 and 2. So now to write factor, you're going to have this, since there's two numbers, you're going to have two groups. Start with the x, and then you're going to put negative 7, just copy as it. Put it out here. Solutions, so you have to solve solutions. You're going to split it up, and you're going to set each of the factor equal to 0, x equal to 7, x equal negative 2. So that is solutions here to be 7 and negative 2, and they are real. You can do this in the graphing calculator, or you can do this with by hand. So let's start with moving the negative 5 to the right. So you can start by writing ABC. Let's start like that, okay? So the A is 4, the B is negative 4, and the C is 5. Right now we need to find the solutions using quadratic formulas. It's going to be B negative B plus or minus the square root of B squared minus 4AC over 2A. Alright, let's plug the numbers in. So negative 4, so you're going to have a negative 4 here. And then plus or minus means there's to be two solutions there. You're going to have a square root. So keep the negative 4 in the bracket. And then minus 4 times 4 times 5 over 2 times 4. Alright, so what we get here, So let continues on. The bottom is 8. That's going to give me a positive 4 plus or minus. So this is going to be give me 16. And 4 times 4, 16. 16 times 5 is 80. So it'll be minus 80. Alright, so this is going to give me 8 on the bottom. 4 plus or minus. You're going to have a negative square root. So 16 minus 88 will be 60, negative 64. Okay, so you're going to have two complex solutions. So 4 plus or minus. You take a square root of 64, so you can rewrite this. Let me do slowly. So it'll be 64 times I square. I'm going to replace negative 1 with the I square. Then be 4, 8 on the bottom is 4, and then plus or minus going to be AI. Yeah, so now I can simplify by 4. I'm going to have two solutions would be 1 plus or minus 2I over 2. So there's two solutions. Okay, so you want to be precise. You're going to have one with the minus, and then you're going to have one with the plus, like that. Okay. All right, let's do number 4. For this one, so you could multiply that out and then you solve it just like number 3. I move the 25 from the right to the left. It turned into negative 25. So let's start if we can with the quick factors. Let's see if any number multiply 25. Two numbers multiply equal 25. 5 and 5, 125. No, it doesn't work. Okay, so we're gonna do the same way like this. But you do it. Okay, so it's same as that one over here. Okay, so it's the same process. So you take the square root of 196, you're going to have 14 minus, and then you're going to rewrite negative 14, negative 16s, that's a 16I squared. Then you're going to have negative 14 minus 4I. 6. Find the discriminant and the type of root. So we have to make this into ax squared plus bx plus c equal to 0. So now let's move it. I'm going to move 9x. I'm going to minus 9x, so it's going to be negative 9x plus 12, so it'll be minus 12. Equal to 0. I'm going to combine this two. Negative 12x minus 12 equal to 0. Now let's find a. Negative 3. B is negative 12 and C is negative 12. The discriminant there minus 4AC. So what is B? Negative 12. So keep the negative 12 in the bracket. Minus 4 times negative 3. Every time you have a negative number, keep them in the bracket. Okay, that may be the best tip that I can give you. So be 144. Multiply all of this. Be 4, so be negative. You have 4 times 3 times 12. 144, so be negative 144 equal to 0. When there's a 0, you're going to have 1 real root. Okay, with um, So the answer is right there in the bottom. So number 7, use decimals. Number 8. So number 8, this x-axis is represent the real number, and this y-axis represent the imaginary part. Okay, a real part over here. So anytime you have a complex number like this, the number without the I we call the real part. So with the I we call the imaginary. So now this is real, real. So I'm gonna box everything that is real. Okay, so those are real. And the one that with the letter I is called the imaginary. So what they want to plot? Okay, so we have to plot all four. Here we go. So the first one is 7. So we go to the right 7, and then we go up 3, positive 3. So this is point A. Point B, negative 5. So negative 5, and then plus 1. And now this is 1 there. Okay, so this is point B. Point C, negative 2. I have to move my screen up a little bit. Negative 2 to the left, and then negative 4 down here. So this is point C. And point D, 0. You don't have to move left or right, but you move down 5. So that's how you plot the complex number. All right, to simplify this, you need to multiply it. You can use the box method. And so you're going to put the number 3 and 9i, and then you're going to put negative 4, 2i. And they use different colors, so you can see that's negative 12, negative 36i. It's going to give you 6i. That's going to give us 18i squared. Now, important to always remember, you cannot leave the I square as I square. You have to make the I square or any I that has the exponent bigger than 2, you need to convert it back into a negative 1. So let's simplify this. So you have a negative 12. Those two can be combined into one single term with the I. So it'll be negative 30 I and then plus 18 I squared. Now the I squared is negative 1. This is a negative 1. Okay, so you're going to keep going. So negative 12 minus 30i. So turn this into 18. Okay, because 18 times negative 1 is negative 18. So now you combine negative 12 and negative 18 to negative 30 minus 30i. So that would be answers. The conjugate, you just have to switch this imaginary to the opposite side. So that's it. Okay. So again, the switch. So what you do, you're going to switch the imaginary part to the opposite side. That's all you'd have to do. Right. Number 11, what is the simplifying form of 4? So make sure you distribute the third power into the whole thing. So you're going to have 4 third power and I third power. Okay, so make sure you do that. So here we go. So 4 to the third power will be 4 times 4 times 4 is 64. I to the third power will be I squared times I. So now I squared is negative 1, so the answer will be negative 64i. All right, to simplify number 12, you're going to group the real numbers together and then the imaginary together. So it'll be negative 5. Now this negative sign needs to be distributed, so it'll be negative 2. So let's negative 29i, and then going to be negative 2 plus 17i. So make sure you switch the sign of every term that behind that negative sign in front of the bracket. So you're going to group those two together, it's be negative 7, and you're going to group those two together. So be negative 12i. The decimals a little bit faster. I'm probably going to pull decimals up and just show it to you how fast it is so you can do this. So let's say it's above. Above mean higher, more. Okay? You can say higher, or you can think of more than, okay? Or bigger than, right? Or bigger than. So something like that. So you have to start with negative 16t squared plus 36t plus 10 greater than 25. So put it here, you can say greater than. So it's those kind of meaning when they say above. When they say below, then the other way around. Okay, so it depends. Sometimes you're going to have an equal sign as well. Calculate the root. So you can do this using the quadratic formulas, but they didn't say that what we have to show your works or anything, and we can use decimals. All right, so after I put this in, I'm gonna find the root. So the root is this 2. So it's happened to be a decimal, but that's gonna be fine, you know. If you want to use exact solutions, you can do it with quadratic formulas. But for this one, you can use the decimals. So you can, again, you're going to make this, you're going to graph this. So you're going to move the 15 to the left. Then you're going to simplify it. So at the end, this is what you're going to graph. Plus 36t minus, this is over here, 25. So that's what you're going to graph. So then you're going to have the x. So let's pull up the x again. So let's just take 0.55 and 1.70. Okay, so 0.55 and x is equal to 1.69, but round it up to 1.70. So let's set the root. Plot the root on the number line. Divide the number line into 3 intervals. So between 0.55 and 1.70, the 1.55 need to be over here and 1.70 over there. So you don't have to be exact. You just have to put the numbers in the correct order, the smaller numbers to the left. So now we want to test it out to see to do part B. So you want to test it out. So what you mean by test it out? So let's start with the left hand. So if you pick, so you just pick a numbers that over here. So smaller than 0.55, you can pick x equal to 0 or t equal to 0. I mean, this is t. T is actually mean the same. So you can pick t. They say t. So you can say t is 0. Then you're gonna plug in. So you're gonna uh, plug in the equation y. This is the equation y right there. Okay, that what I'm talking about. So then you plug t equal to 0, y equal to negative 15 is less than 0. Okay, now, next one you're going to pick, so I'm going to use different colors to show you what we're doing. So let's put the green. So I'm going to pick the numbers in here. So with the number between 0.55 and 1.70, you want to pick the easiest number that you can do. So equal to 1. And then you're going to plug in the y. So it's 1, so you're going to have a negative 16 times 1 squared plus 36 times 1 minus 15. So this is going to be negative 16 plus 36 minus 15. This is going to give me positive 5, which is greater than 0. All right, next one. Let's pick, what color should I pick? Blue? Okay, pick blue. So I need to pick that numbers right there. So you see you have 3 intervals, so now we're going to pick t equal to 2. 2 is greater than 1.70, so 2 is good. And then again, I'm going to plug in the y. So it'll be negative 16, 2 square times 2 square. So be careful with that. 36 times 2 minus 15. So 16 times 4 is 64, so it'll be negative 64. 36 times 2, 72, minus 15. 64 and negative 15, negative 64, negative 15 would be negative 79. Negative 79 be negative 7, less than 0. So you have two things here. Less than 0 is negative. Greater than 0, you're going to have positive. And this is negative number. All right. So now identify the solution set as the interval. Now, what do we need here? Over here, okay? We need greater than 0. So when it's greater than 0, it's going to be a positive. So we want positive. So what's positive? It has to be this one. Positives right here. So positive is the green region. So which is between 0.55 and 1.70. So the answer would be 0.55, comma 1.70. So that's it. All right, this is the lesson that we did recently. So, but I'm gonna go over what I can. So here is you have the degree is 8. So you expect to have 8 root. Okay, so that's your so whatever the degree is, that's how many roots supposed to be. Okay, so here let's take a look. Let's use different colors here. Let me explain to you one more time on how to use the graph to find the root. Okay, so here we go. So look for the x. So again, look for x-intercept. First thing. And then the next thing is how the graph. The graph, how is the graph at those x? Okay, at those x-intercepts. So over here you have x equal negative 2, but this is bounce off, right? It's bounce off, so you're going to have the multiplicity multi equal to 2. When it bounces off, you're going to have multiplicity at 2. So x equal negative 2, so how do we write it? We write out x equal negative 2. Now, if you want to write in the factor, you can write down. So let's kind of split this up so you can write it down. So you can write down x plus 2, and then multiplicity is 2. So you can write like that. Okay, the 2 exponent like that. All right, let's move on to this guy right here. So x equal negative 1. So for factor, you're going to write down x plus 1. Now, when it goes straight through, you can see it goes straight through. It's going to have the multiplicity is 1. So then you're going to put 1, and then you're going to put exponent 1 right there. Okay, so now you don't want to do this one. Always going to do this one last. Okay, last. So again, that's important. You want to do that x-interception last. There's a reasons for it. But let's start with this. So that's x equal to 1. What does it look like? Bounce off. Bounces off. So the multiplicity is 2. Okay, so we're going to have x equal to 1. So for factor, we're going to write out x minus 1. The multiplicity is 2. We're going to put 2 right here. So whatever the multiplicity is, that is the exponent. So we got that. So now let's go to, this is the 0. Okay, so again, it's slowly in and out. Okay, slowly in, out. The degree, the multiplicity is going to be 3 or better, 3 or higher. Okay, so let's think about what's the degree. So the total degree is 8. Okay, so the degree is 8. And now what we have here, 2 plus 1 is 5. So you're going to minus 2 plus 1 plus 2. Again, all from here. Okay, so you're going to minus all of this right here. So there's going to be 3. So the multiplicity is, so when x equal to a 0, then the factor, you can write out x plus or minus 0 is still the same. So you have to write it, the multiplicity is 3, and the exponent is 3. So let's think about it. 2 plus 1 plus 2 plus 1 is 3. We're done. So easy to get factors. So to rewrite the whole thing as factorized, to rewrite the whole thing, let's start with the biggest degree. So x3, x plus 2 square, x minus 1 square, x plus 1. You can write 1, or you don't want to, you don't have to. So that's the answer. Now, if you graph this, and the answers graph, they look different, right? They look different. One, this is we call the standard. Okay, this is we call the factorizations. So they don't look the same, but they are the same. So if you if you graph the standard and you graph the factorized form, it's going to be exactly the same graph. So try that. So when you have the degrees even, so let me kind of go give you a quick um, summarize of the degree when the graph is even degree or odd degree. Okay, so when it's even, the graph going to be either go this way or this way. Okay, let's go up. The leading coefficient is going to be positive. When it's down like this, the leading coefficient is going to be a negative. The leading coefficients. So when the degree is even, the two ends always go at the same directions. Now, if it's odd, it's going to be like this or going to be like this. Okay, so it's going to be like that. So this is positive, this is leading coefficient negative. And now let's match this with what we have here. Okay, what we have over here, we got look exactly like this. Okay, look exact. So I'll explain to you even and not. So let's see what is matching. It's matching the odd, so we write down the answer is odd, and the leading coefficients negative, oh, it's positive. Okay, so the maximum is the highest point. So let's find the maximums right here. This is the maximum. So the max is negative 4, 5. This point. So right here. The x-intercept, let's write this over here, is at this point, so be negative 5, 0. It's a point. I guess we can do, there's something missing there, so we can do a minimum. So the minimum is right here. So be negative 2 and 1. 1 is here. The behavior, so x goes to negative, so this is negative of the x, and this is positive x. So negative, the graph go down, so it'll be negative infinity, and this one's positive infinity. So this one, find a 0, so there's 3 groups, so you're gonna have to solve 3 different equations. X plus 2 equal to 0, x minus 1 equal to 0, and then you're gonna have x minus 2 square equal to 0, like that. Alright, so you're going to have x equal to negative 2, x equal to 1 here. Now, for this x minus 2, square is the same thing as x minus 2, and then you have x minus 2's again. That's what it means. So then you have the multiplicity is 2, so you can just solve for this with x equal to 2. But you're going to have multiplicity is 2. That means you're going to have 2 x equal to 2 solutions. So how do we graph it? First, we need to find those x-intercepts. So negative 2 is 1. 1 is another one. And then you're going to have 2 is another one. So make sure you know that the 2 is bouncing. So you sketching, okay? You sketching. You don't have to be perfect. You just kind of show it. So the leading coefficient, we need to know the leading. So the leading coefficients is positive. Okay, so it's positive, this positive right here. So positive's right there. Those no negative signs, so it's positive. So that's mean the graph gonna be like that. So the two end behaviors kind of go up. So we know this is gonna be bounce off right here. Okay, because the multiplicity is 2, so we can draw, for example, again, there's don't have to be exact, so you can draw something, I don't know, something like that, and you go down, you bounce it off, so you're gonna be like that. Okay, so you can see this one go through this point, so this is negative 2, 1, 2. And they both end behaviors that go up. So that's how you sketch a graph. So number 4, real zero, absolute minimum, and behavior. So the numbers of real zero, there's the x-intercepts right here. So you can say 1 and 2. The number of real zero is 2. So it's 2 because 2 x-intercept. So the x-intercept give you the real 0. Absolute maximum, this is maximum, maximum. This is the absolute max. And this is the relative max. So the absolute max is as, I guess we can say 1.5, 3. Minimum is right there. So be 0, -2. Relative max would be -1, -1. Relative minimum, so it's the same thing as this two. So 0, -2. There's only one minimum. So and behavior, they're both going down. So the standard form, so the highest degree, so you have to put this in the order from the highest degree. Okay, so order from the higher degree to the list, and then number, a constant. So that's a standards mean. So this one is wrong. This one is wrong. Let's find the right one. So this is right. This is wrong. This is wrong. This is wrong. So if the degree is 3, so we know the degrees to the total of multiplicity, whatever it is, going to be a 3. Okay, so and I 2i is a root 0, so we have another real root right here, so which is at 4. So you can write like this. So we know x equal to 4, and this is the real root of 0. Then you can write down. Now this is go straight through. Okay, so you can write a factors x minus 4 for this one straight through, have multiplicity of 1 and 2i. So we have to have the degree of 3, so we can write down the x. So we have to know that this is going to be x equal to 2i. Start from there. Then we're going to have x minus um, 2i, and then multiplicity of 2. So we can do it like this. Okay, um, that's is the thought process. Okay, so but we have to in the polynomial we're not allowed to have the I. We're not allowed to have the I. So we need to, if you want, you can multiply this and to get the answers, but we can do it by just kind of simply put the 2 like this and then think of what do you do if you have x squared that gonna give you this kind of solutions. Okay, that. So you can square both sides like that. Okay, and then you're gonna have 4i square. I square is -1, then -4. Then you're just gonna put -4 here, and then you're done. Okay, so now you're gonna have the solutions of 2i. So that's the answers. And behavior, you can do all of that. Factor, find the root. Should I do it? No, you do it yourself. You do it. So this one over here. So what you can do is you need to think of the numbers that you can apply. You have to have something like this, or you have to have something like this. All right. So you have to have AQ minus BQ or AQ plus BQ. There's a minus, so it's going to be this one. So to get A, you have to take um, the Q root of 8 is going to give you 2, and you're going to take a Q root of 27. You're going to give you a 3. Then you're going to rewrite this as 2x keep in the bracket q, and then you're going to minus 3q. And then you're going to use the formulas. It's on the formula sheet, so you don't have to memorize this, but it's like this: a square plus ab plus b squared. Because then you just going to continue to write this as 2x minus 3, and then another group, another factors, you're going to have 2x, keep this 2x in the bracket like this. And every time there's two numbers combined, keep them in the bracket. Every time there's a negative, keep them in the bracket. 2x times 3 plus 3 squared. And you simplify this. There's nothing you can do there. You're going to have 4x squared minus, again, this is multiply 6x and then plus 9. You're done. So same thing as that right here. You do it yourself. Okay, trying to do it. The volume is the height times the width times the length. So when you fold it up, you're gonna have the box look like this. So when you cut the four corners out and you fold it, it's gonna be the x. And at first, the width is 11 from here to there. Okay, 11. But then you take out this 2x's. So the width, you're going to have 11 minus 2x. And the same thing with the length, you're going to have 19 minus 2x's. Because 19 is all the way from here to there. Then you're going to plug it in, x, 11 minus 2x. And then 19 minus 2x. And then you're just going to use in the graph to find the max volume. Number one, you're going to have this function. First, you're going to graph it. So this is the graph. When they ask you for the transformations, you need to graph the parents. So this is the parents of the rational functions. So let me uncheck the functions so you know what the parents look like. Okay, so let me write it on here so you know what the parent is. So the parent of the rational is 1 over x. To find the transformations, you need to know how this f of x transform from here. So we want to know how from 1 of x transform to the f of x. So let's take a look at the graph on decimals. So the parents and the functions. So what happened to it? So first, if you notice, you just have to pick a point. I think the best point to pick is this point right there. Okay, and then you're gonna compare with this point, and then you'll see how it's transformed. Because right now, so many graphs, you don't know what point to pick. So you look like this graph has been reflexed. So if you notice that we learned the transformations before, with this minus over here, it's gonna reflect over the x-axis. Okay. And then it's gonna, so when it has minus 7, it's gonna move down 7. And if you have the force right here, and then you have a 1 right there, so it's a plus 1, it's gonna be to the left one. Okay, so the horizontal asymptotes. So let's uncheck this parent because we don't need this no more. Okay, so that number 4 just shrink. You can't really, you barely see the shrink. Okay, shrink by 4. So you barely see the shrink because the graph is too small for you to really see it. Um, so we don't need the patterns to do the rest. So the horizontal asymptotes is the line that in between these two, so that these two blue graph would never touch. So thinking of this, I was thinking this one over here. Then you can test it out by put your graph in. So this is going to be, this line is the y-axis. So that number is at zeros there. So it looks like it's going to be -7. So I'm going to try to type in y equal -7. Yep, so you see the purple graph, purple line. And if you move it all the way, you can see there always a little space between the asymptotes and the graph. So we got that one right. So asymptotes y equal -7. Domain. So the domain is the bottom, cannot be a 0. So x cannot be -1. Now the range. So you look at the range. It's everything from negative. The range is the bottom to the top. So everything but at -7. So you have to take that -7 away. So there are different ways you can write it. You can start by writing all real except -7. That's how you want to spell it out. So you can say all real um, except um, y equal -7. You can say that, or you can write that negative infinity to -7, and then open the bracket again, -7 to positive infinity. That means there's no equal to -7 there. Now the end behavior, so you're gonna have, be careful with this, right? So x go to negative infinity, where the graph is going to -7. Okay, look at this right here. So negative infinity go to the left. So every time negative infinity, x go to negative infinity, is going to the left. So where the graph is going to the left, get closer to y equal to -7. If x going to positive infinity, right over here, right? So go to the right. Where the graph is going to the right, it getting closer to y equal -7. So be y equal -7, and same thing with this. So be careful with the end behavior. That. All right. So this one over here, we have to factor this. So we're gonna have x minus 9 and x plus 9. This is the formulas that we learned in the class. A minus b squared, a squared minus b squared, a minus b, a plus b. So what happened? X is a and b is 9. On the bottom, thing up to number times 54, -54, and when you add, you get 3. So be 9, 6. You want positive, so the positive number is going to be a bigger number, so plus 9 and x minus 6. So the whole is when you can cancel it, so you can cancel this too, right? So that means x equal to -9. The vertical asymptotes would be x minus 6 equal to 0, so be x equal to 6. Horizontal asymptotes, these two have the same degree, and you have coefficients 1, so the horizontal asymptotes y equal to 1. So horizontal will be, what number is this? 2, so be -1 there. So let's do it quickly. So this is y equal -1, this line right there. And the vertical asymptotes is at -3, x equal -3. The end behavior, they both left. See, this is left. This is negative infinity. This is positive infinity. Go to the right. they getting closer to y equal -1. So you don't have to write y, you don't want to, just like that. Because they say p of x, so p of x is the y. Okay. The whole uh, is right here. So this is the whole right there. So what is this? X equal to 4? -4? I can't see. Domain, all real but those two. So you say all real is f x equal -4, which is the whole and the vertical asymptotes x equal -3. So the whole and the vertical asymptote you need to be taken away. Now the range you need to take away the horizontal asymptote. So you say all real is f y equal -1. Okay, you figure that one out. And that's it.